A very good day, doctor. My name is Thomas, son of Thomas Silvan. Today, I would like to show about the on-off controller procedure. So, first of all, this is a step. And this one is relay, sum, and then transfer function. This one is for constant value, and then another sum, and also marks, scope, and sim out. So, once we complete the circuit, complete the block diagram. So, first we have to set the value, final value as 85. Then click OK. Then go to simulation, click model configuration parameters. Then here we have to set the start time as 0 and the stop time is 5000. And then we have to set the solver selection type variable step and also solver ODE 45. And then solver details. We have to set max step size is 1, minimum step size is 0.99, and the initial step size is 0.992. So after we set everything, then click apply and OK, and then click on off controller, which is relay, and set this switch on point is 3 and switch off point is -3, and then click apply and OK. So let's see the what is the response from the this block diagram. So this is the response from the based on given values in the lab instructions. And then for the following task, we have to change the value of the switch on point and switch off the switch off point. So now I would like to set 1 and switch off point -1 based on given values in lab sheet. Click apply. Okay. So this will be the response from the based on the changes from the relay. And lastly, we have to change the switch on point to 6 while switch off point is -6, and then click apply. Now let's see the response. So these are the response from based on changes in relay. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Nurnishaira binti Abu Bakar and my message number is E10222. I'll do experiment for 5.3.1, which is for P controller. For P controller, we use three value, which is 0.0024, 0.0009 and 0.005. For P controller, we need to change value at proportional gain, KP. So here we already set the KP to 0.0024, and then we run, so the scope will detect and the graph will be like this. Value is 0.0009, and then we run, so we get the answer like this. And finally change the value to 0.005. And this is the final answer for 0.005. So that's all from me, and thank you.
Hello, my name is Suresh Anlaki Sukurmaru and my metric card number is CE19007. Today I'm going to present about the part B, which is the PI controller. As you can see right here, this is the controller. So now we are required to set the derivative gain, integral gain and proportional gain. So these are the values given, provided to be set. So for the integral gain, there's three values. which is the numbers ending with 432 and the numbers with 632 and 222. So for the first graph, this is the graph we obtained for the numbers ending with 432. Moving on to the second, which is the 632. So this is the graph we obtained for the numbers ending with 632. And lastly, 222. So these are the graphs. So that's it for me. Thank you.
Greetings to Doctor. My name is Wong Si Hui, matrix number AE190146.
So now I'll continue with the part C, which is the PID controller, where I'll be need to set the proportional gain KP, integral gain KI, and derivative gain KD according to the parameters given in the lab sheet. After that, we will run the system and click the scope to observe the response. So this is the results obtained with derivative gain as 0.2175. Later on, we'll replace the derivative gain to 0.5 and repeat the procedures where we will obtain this graph as the scope result for 0.5 as derivative gain. Then we will replace the derivative gain again to 0.0575 and observe in the scope again, which we obtain these results. Then we will proceed to part D, which is the PID controller tuning, where we need to adjust the parameters of proportional gain, integral gain, and derivative gain of the PID controller to achieve the specifications of settling time lesser than or equal to 2700 seconds, as well as the percentage overshoot less than or equal to 30%. In the system, I have adjusted the parameters of 3 of the gain of the PID controller, where I set the KP to 0.002, KI as 0.000006, and KD as 0.0005. After running the system, we will obtain this scope result, where we can use the tools to observe on the graph to see on the specifications, as it doesn't show the overall data that we are required to know whether we fulfilled the achievement. I will be using the MATLAB to do the calculation to obtain the results. So from the system, I have added 3 extra tools to transfer the data to the workspace in the MATLAB. Then by using the coding they have constructed in the MATLAB, we run the coding and the MATLAB will be using the data transferred from the system in the Simulink and obtain the specifications of the percentage overshoot and settling time to see that we have achieved the specifications, which is the TS is less than or equal to 2700 seconds and the percentage overshoot is less than or equal to 30%. So that's all from me. Thank you very much.